Hello there, Mr. Sutton here, bringing you this AB Calculus 3-6 lesson on derivatives of trigonometric functions. In this one, as the title suggests, we will be finding derivatives of those functions. For your warm-up on this one, just to connect old knowledge to new knowledge, find the derivative of the sine function on this graph. All right, let's see what you came up with. So hopefully you were checking first for critical values, like these smooth turnarounds here, and there's a bunch of them. An infinite number actually, because it's sine and it just keeps repeating. Next, let's figure out the direction of our derivative. So here we're increasing, so we should have a positive derivative, and then decreasing here, so negative derivative, positive, negative, positive. So starting positive then, we've got to go through here into negative land, and then back up here into positive land, and it just keeps going back and forth, much like the sine function itself. In fact, hey, bonus points if you can identify this function here. Is there any function that starts at 1 and keeps oscillating between 1 and negative 1? Oh yeah, it's the cosine function. The derivative of sine, then, is cosine. That's kind of cool. So I'm going to give you the derivatives of the 6 trig functions. Now, we already proved that the derivative of sine is cosine. We're not going to prove any of the other 5, but I'm sure you can find any number of YouTube videos if you want those proofs. So cosine, it turns out, ends up becoming negative sine of x if you take its derivative. Derivative of tan is secant squared. Derivative of cotan is going to be negative cosecant squared. Secant's derivative is secant tan. And then cosecant becomes negative cosecant cotan. Now, just a couple of tricks for memorizing these. C's are bad is the one that I like. So you'll notice that the derivative of all the trig functions that start with the letter C happen to be negative. Coincidence? Probably not, but who knows. Another thing here is I made this Quizlet at this address, so feel free to go there on your own time and play the game that helps you remember these. One other little tip that I heard is that when you have a tan or a secant involved in a derivative, there's always 2 tans and a secant involved. So if your tan is over here, you've got the 2 secants over here. If you've got a secant, then the other secant and the tan are over here. And the same kind of relationship works with cotans and cosecant squareds. So you'll find ways of memorizing these, but you do need to memorize them. So now that you've seen some of the basic trig derivatives and hopefully gotten a chance to practice them, let's use those in larger problems. Pause the video and see if you can figure out the derivative of this first example. Alright, so we're just going through term by term, just like as if it were a polynomial. Derivative of sine of x, we remember, is cosine of x, and the 2 is just along for the ride. You do not need the product rule here. So this is just 2 cosine of x for that first term. And then the derivative of tan is secant squared of x, so this is minus secant squared of x. All right, pause the video and try this next one out. All right, so going through term by term again, and this is a mixture now of polynomials and trig functions. This first one is just a simple power rule, so 40x to the third. And this next one's a little trickier. X times cosecant of x, we're going to need the product rule here. There's no way to simplify this. And this is not just like a regular coefficient like a 2 that's just along for the ride. So using our box and ribbon here, we've got x and cosecant of x, and their derivatives, which are going to be 1, and derivative of cosecant is negative cosecant x cotan of x. Using my ribbon now, I'm going to have plus 1 times cosecant of x plus x times negative cosecant of x cotan of x. And they said don't simplify, so you can actually just leave it like this and call it a day. For this next example, we're trying to find the slope of y equals 1 over x plus 5 cosine of x at x equals pi. Pause the video and give this one a shot. All right, so if we're trying to find the slope, that means the derivative at a specific x value here. So let's find y prime first. I'm going to rewrite this as x to the negative 1, just to make it a little easier to use my power rule. And now going from left to right, I've got y prime equaling negative x to the negative 2, and then minus 5 sine of x, because negative sine is the derivative of cosine of x. Next, we have to plug in pi for everything. So this will be negative pi to the negative 2 minus 5 sine of pi. And at this point, you're actually done. These are all constants. Sine of pi is a constant. Now, of course, we hope you know that sine of pi is really 0, so this whole second term goes away. And you could rewrite this then as negative 1 over pi squared, but totally unnecessary unless it's a multiple choice question. For this next problem, we have a function with trig functions in it that we're being asked to take the derivative of, and this time we're being asked to simplify. So pause the video and at least get to the unsimplified version of this, and then we'll bring it back together. All right, in order to get going on this one, I notice that we have a quotient, so I am going to use the quotient rule. That's u prime v minus uv prime over v squared. Let me set up the box and ribbon to help me with this. So for my u, I've got my numerator, cosine of x. For my v, that's my denominator, 1 minus sine of x. That goes right up here. And now the derivatives of these, for cosine, that's going to be negative sine of x. And for 1 minus sine of x, derivative of 1 is 0. A negative sine of x derivative is negative cosine of x. And at this point, we're going to go through and use the ribbon to multiply it all out. So I've got negative sine of x times 1 minus sine of x, minus, going the other way now, cosine of x times negative cosine of x. And we've also got this stuff down here squared, so 1 minus sine of x, the whole thing squared. So at this point, if you've gotten this far, that's pretty good. Unfortunately, sometimes you have to go a little bit further, especially if it's a multiple choice question and you have to match one of the answer choices. So for the sake of that, pause the video again and see how far you can simplify this. Now when I'm simplifying trig functions, I have my acronym that I go through, PACS, P-A-C-S. The P stands for Pythagorean identities. The A is algebra, and the C and the S are cosine and sine. So I'm looking for squared trig functions first, and I don't see any. So my next thing I'm going for is just plain old algebra, multiplying stuff out. So this negative sine of x can get distributed. This is negative sine of x, and then we have plus sine squared of x, and my denominator is not going to change at all. You could expand this, but it turns out it's usually not helpful to do that, so I'm going to leave it as is until I see a need to go a little bit further. And now for this other piece up here, we have a negative and a negative giving me a positive cosine squared. At this point, I've got some squared trig functions, so I'm always thinking, is there one of those identities I could replace things with? Now it turns out sine squared plus cosine squared, that whole identity, really just has a value of 1. And this is one that you are kind of expected to remember. There's two other ones that don't show up as often, but you do need to know that this equals 1. So this is negative sine of x plus 1, or 1 minus sine of x, you could write that as, in the numerator. And now it just so happens we have a 1 minus sine of x squared downstairs, so we can cancel out one of those, leaving me with just 1 over 1 minus sine of x. And that's about as simplified as this thing is going to get. We'll do one more problem to wrap this one up. Pause the video and give yourself like 30 seconds to do this one. All right, did you use the quotient rule? You didn't have to. If you simplify your trig identities in the beginning, for example, 7 over tan of x, that's really like having 7 times cotan of x, the reciprocal of tan of x. If you do some simplifying in the beginning, usually you have a lot less work to do on the derivative. Now the derivative of cotan, that's just negative cosecant squared, so then negative 7 cosecant squared of x would be our derivative. So that's it for this one. We're done getting triggy with it. Until next time, Mr. Sutton signing off.